Hello, Algebra 2ers. Today is a big day in Algebra 2 because we're finally getting to the reason about why we are even learning about our exponents and our logs. Okay, so today we're going to start with solving exponential equations using the logs to help us do so. And you're going to need something to write with. You're going to definitely want a calculator, okay? And you might want two screens opened on your computer, as you might want to use the website I'm attaching to this because your calculator might not do logs for you. And you're definitely going to want your notebook out so you can get good notes written in your notebook so you can refer back to them as you work on the assignment. So let's get started. So we kind of touched on this just a little bit in our converting video, but we have two different types of exponential equations. So there's a type where we have exponents on both sides, and when that happens, a lot of times it's going to be our same base, okay? So this is when we have the two equations on each side. This is when we would have or solve or try and solve using the same base. Okay, but there's also equations where we have exponents on just one side. And again, you could try solving with same base, but a lot of times when this happens, the odds of being able to do same base are far and few between. So this is where we might have to use the trick of logs. So as we jump forward again, have both of these in mind, okay? We have exponential equations where we have exponents on both sides, but we also have exponential equations where we only have an exponent on one side, okay? And there's different ways we go about solving each equation. So as we jump forward here, we first need to talk about how we're going to calculate today, okay? So we are going to start calculating our logs today. The link on the screen, okay, that takes you to a calculator online where you can just type it straight into that calculator and get an answer back. Or if you have a calculator of your own that you want to use, those work, most of those work as well too. So the other calculator you might have is this one. Okay, this one, you can see that there's a log button. If you're going to use the log button, okay, all logs are written as log base b of a, right? So if you're going to use the log button, this is the equation you're going to have to type in. You're going to want to type in log of a over log of b. So that means you put log and then you type the a value in and then you divide by log value of b, okay? So that gets a little bit confusing, and so if you want to learn how to do that, I can definitely help you. Or you can use the online calculator for now, since it's a little harder for me to help from a distance, okay? But there's also some of us that have this fancy calculator. So in this fancy calculator, in order to find your log button, you have to hit this math button right here. And then once you hit the math button, you hit the up arrow, math. I'll write this out, math. Then you want to hit the up arrow, and then the A option should say log base. And when you type that in on your screen, it should give you basically what you see in your calculator on the computer over here. So again, if you have questions on how to use your calculator for this, just make sure that you reach out and ask. I can do my very best to help you get those answered, but the online calculator might be the best as we kind of work through this today and you're learning. Or you can use this equation right here. This is the change of base equation. So you could also use that on this calculator. You can use the log button right here if you don't want to use the math button, okay? So you can use your change of base on either calculator that you have. But if you have questions on how to use that, just reach out and we can get those solved. But for the sake of learning today, maybe just using our online calculator. So let's see what I mean by calculating logs. Okay, so let's look at exponents on just one side. So here, it's giving you step by step. So isolate the base and then change into log form. But for starters, let's see if I can do the change of base here. Well, in order to do a change of base, I have to have two bases standing alone. So let's get this 1 out of here. So I'm going to have 2 raised to the x equals 7. And I think it's pretty clear that 2 is not going to be raised to any exponent that will give me a 7. So this is when the instance of our logs has to come into play. Okay, so we're going to have to change this exponential into a log form, because when I do so, you'll see something that will happen, and it's going to help us solve for this exponent of x. So what number do I need to plug in here to get back a value of 7? So again, if we were to change into log form, since I'm in exponential, that's when I make my L. Okay, so then I do log with that base of 2 of 7 equals x. So now when I did that, I get the x standing alone. Now, log is just like a function. It helps us to figure out, this is again figuring us out what this exponent is. It's a function that helps us to figure out unknown exponents. But when I have all numbers in here, this side is just going to be one big number. So here's where you could go into your calculator on the computer and you could type in log with a base of 2 of 7 and then hit equals. Or if you're trying to use your calculator, you can take log of 7 divided by log of 2. And so I'm going to do that second one. I'm going to do log 7, close my parenthesis, divided by log of 2. And the number I get back would be 2.8074. And with logs, we like to go 4 decimal places because the more accurate we can be, the better. So if you aren't getting the number 2.8074, make sure you star that, and I can help you as we kind of go forward in this to figure out how to find that out on a calculator. And again, you can use the online calculator or you can try and use your own. So our answer for this one, the exponent that I would need to put on 2 would be 2.8074 to get back an answer of 7. So make sure you jot down any questions you might have as we kind of move through these because it's a little bit of foreign territory here. Okay, example 2. Okay, right off the bat, I'm going to tell you that we can't do same base here, and I think a lot of you are probably realizing that I can't raise 10 to anything to get me a 55. So again, we're going to have to isolate and then change into our logarithmic form. Okay, notice our exponent or our base connected to an exponent is already isolated, so we can just jump straight into converting here. So when I convert, again, I'm going to log form, so I want to make a G. So start by writing log base of 10 of 55 equals 3x plus 2. Now this one's a little bit different than our first example because it looks like our exponent has more to it than just an x. So again, this log over here is just a number. So in my calculator, I can type in log 55 over log 10, and that would give me an answer, or you could use your math button. However it is you have to get to an answer here. But then when I get on the left-hand side after you calculate it, it should be the value 1.7404. And again, let's go 4 decimal places when we're finding that log number, or helping us figure that out because we want to be as accurate as we can be. Okay, but this still equals 3x plus 2. Now from this point, hopefully we see that this is just an algebraic expression or algebraic equation that we have solved for many years now. So all I got to do now is focus on getting that x by itself. So the first thing I'm going to do is I'm going to subtract 2. So in my calculator, 1.7404 minus 2, looks like I'm going to get back a negative answer. So the number I get back is a negative 0.2596. And that equals 3x. Again, x isn't alone yet, so I'm going to take both sides and I'm going to divide it by 3. So in my calculator, I can just hit divided by 3. And it looks like the answer that I get back for x is negative 0.0865. And again, if you're not getting that answer, I would try again. Try typing in your calculator, maybe try a different avenue. But understanding your calculator is going to be really important throughout this process because it's going to help you to get the right answers or not. Okay, so make sure you jot down any questions you have as we work through this, whether it's a calculator question, a question on how I set up the equation, how I'm doing the steps I'm doing, okay? But jot those down so we can make sure that we get those answered. So our final example then for today is a mix of our first example and our second example. And again, in order to use the same base, we'd have to have a base on one side and a number on the other. So we want to first off isolate. So we're going to subtract this one. Get that 3 raised to the exponent standing alone. So 3 raised to the x minus 2 has to equal 86. Now I could take some time and I could figure out, okay, can I raise 3 to anything to get an 86, but I'm going to save some time and tell you that you can't. So again, we're going to have to convert to our logs. So again, whenever the same base doesn't work, that's when we use the logs. Okay, so convert to our log, make our L or our G. So log with a base of 3 of 86 equals x minus 2. Okay, so and again, since my log involves a base of a number and a whole number inside of it, that means it's just going to be a number. So I'm going to type that into my calculator and see what I get. So I'm going to take log of 86 over log of 3. If you don't know how to do that, make sure you jot that down and we get that question answered. Okay, that gives me back a number of 4.0545. And this all equals x minus 2. So again, we got to get that x alone, so all I'm going to have to do is isolate that x, and this one's a little simpler than the last one because all I have to do is add 2. So it looks like x is going to equal 6.0545. All right, so if you have any questions on how I solved any of these equations or how to use your calculator, make sure you jot those down and get those answered so you can do this assignment without hesitation. Okay, so I want to thank you for taking good notes, and I will see you when I see you.